Hello friends, welcome to our channel. Let's have a look at an earlier problem 205, Isomorphic Strings. This video actually is a quick follow-up video for problem 2900. So here again, our method will be index partition. But here the index is in terms of a format of dictionary. So here we are given two strings, S and T. So we want to determine if they are isomorphic. So this second graph is a definition. So if the character in S can be replaced to get a T, so all occurrences of character must be placed in with another character while preserving the order of the character. This is actually very important. So here, in order to quickly do it, I'm going to directly look at example 3. So for example 3, so if you look at the P, actually it appears in index 0 and index 2, right? And A in index 1, and E index 3, and R in index 4. So if you look at the partition will be something like this. So 0, 2, and 1, and 3, and 4. So notice that this is already in sorted order, right? So now if you look at the T title, so because T appears in 0, 1, and I appears in 1, and L in 3, and E in 4, right? Again, the partition, if you sort, is this, right? So the partition basically not giving the account, the frequency, every character should be replaced. And then also if you sort, it also catches the preserving order, right? Therefore, if the corresponding partition of the indices in sorted order are equivalent or matching, then the two strings S and T is equivalent. So actually we can see like this: S is equivalent to T in the sense of this problem. It means that, or if and only if, the sorted partition, let's call it F of S, T are equal. You can do something like this: F, S equals F, T. So here F is the sorted partition, in other words, this guy. So then actually, in order to do this problem, we just need to get the sorted partition. This is rather straightforward. Let me write a function to do this. I'll just call it partition function, right? So basically, given a string, right? So what do? You can have a collections default dict. So we use a list, right? So then what we do? So for I and character in enumerate a string, right? So what we do is the character. So this corresponds list, I'm going to append I, right? So then what we do? So because dictionary is unordered, so what we want to return is sorted the values. So the values corresponding to those things, right? So here, let me first finish the problem, and then I explain something by printing some information out. So partition S equals partition T, right? First run it and submit that. Yeah. So now what we want to do is to make some prints to see. So let's see. Print S. So it's a partition S. Let me call it again T. So you get partition T, right? So yeah, for the first example, you look at the partition. So S is this. So this partition always also gives you the corresponding substitution. For example, here 0, here 0, corresponding to make a 1 correspondence between E and A. And the 1, 2 the same character, so it means that we have a correspondence between G and D, right? So in the case 2, so we should return false, because here For the first one, you have 0 and 1, 2. Well, for the second one, you have 0, 1, 2. The two partitions are different. Therefore, you cannot make correspondence because there's two unique characters. There are 3 unique characters, right? Because the lengths, so the lengths are the same, but the frequencies are different. Therefore, they're unique. The characters are also different. So similarly for case 3, so you have 0, 2, 0, 2 in the first one corresponds to P, and in the second one corresponds to T. Therefore, we need to map P to T or T to P. Well, for at index 1, so A to I, right? At index 3, E to L. At index 4, R to E, right? So this will be the third example. I guess here, as I mentioned in the video for problem 2900, so in that problem, the partition is in terms of list. So here the partition is in terms of a dictionary, and then we do a sort to get a list, right? So essentially the same thing, but in terms of data structures and the procedure are slightly different. So it's good to notice the delicate difference, right? So with that said, I guess that's it for the current video. Thank you for watching.